Okay, we're going to talk about what a rational expression is and then how to simplify a rational expression. So we are in notes P.5. So the quotient of two polynomials is defined as a rational expression. And remember, we talked about polynomials. Polynomials have variables with whole number exponents, so like 0, 1, 2, 3, and real coefficients. So something like a polynomial could be something like 2x squared plus 9x plus 7. That would be a polynomial. So if we want a rational expression, we're going to have the ratio or the quotient of two polynomials. So here are a couple of examples. 1 over x, where 1 is a polynomial as well. It's just that the x is raised to the 0th power. Or something like 2x squared plus 5x plus 3 over x plus 7. Recall that a fraction is in simplest form if the numerator and denominator have no common factors aside from plus or minus 1. That's how we simplify a fraction. Since a rational expression is a fraction, in order to simplify a rational expression, we first must factor the polynomial expressions in the numerator and the denominator. Then we're going to cancel out common factors, keeping in mind the domain of the rational expression. Okay, so if we have a factor that would make the denominator 0, that's not going to be part of the domain. We're going to talk more about that. So the key to simplifying rational expressions is factoring. So what we learned in the last lesson, we're going to be practicing today. We're going to simplify two rational expressions in example 2, and then afterwards we're going to state the domain of the simplified expression. So we're going to begin by factoring. The numerator, x squared minus 16, this is a difference of perfect squares. So I'm going to factor that as x minus 4 times x plus 4. The denominator, I'm going to rewrite that in standard form. I'm going to put negative x plus 4. And then I'm going to continue to factor the denominator. I want to make it so it's not the opposite of x, but just x. So I'm going to rewrite the numerator, x minus 4 times the quantity x plus 4. I'm going to factor out a negative 1 from the denominator. That will leave me with x minus 4, factoring out negative 1. And now we can see that we have a common factor between the numerator and the denominator, which is x minus 4. We're going to cancel that out, leaving the expression. We'll have in the numerator x plus 4, and in the denominator negative 1, which we would rewrite as the opposite of the quantity x plus 4. If you want, you can distribute that negative in. Okay, but this is a key idea here. When we canceled out this x minus 4 here, when we canceled this out, we actually changed the expression because in the original expression 4 was not part of the domain, but in the simplified expression there's no issues with 4. I can put 4 into the expression, the opposite of x plus 4, and there's no issues. So as soon as you cancel out that x minus 4 in the denominator, you need to remember to write that x is not equal to 4. This is this simplified expression. We need to include that x is not equal to 4. And then we're also going to include the domain because the problem asks us to write the domain. So I'll put that here. The domain of this expression is all real numbers, but x is not equal to 4. That's going to be our domain. All right. So it's important to remember that you must list values that were excluded from the original expression, even if they're not apparent in the simplified expression. In this case, it would be x is equal to, can't be 4. Okay, let's try the example in letter B. So in letter B, I'm going to begin once again by factoring. So I'm going to factor the numerator. And this has 4 terms. If something has 4 terms, it only has 3 terms. So let's factor this. I'm going to take out the GCF. Okay, so the GCF of the numerator is x squared That leaves us with x squared plus 2x minus 15. And I'm going to start factoring the denominator. Once again, looking at the greatest common factor, which is x cubed. So that'll be x cubed, and we're left with x squared minus 25. When we factor that out, we'll continue factoring. In the numerator, we have a trinomial with leading coefficient equal to 1. So we're going to factor that. We need two numbers that multiply to negative 15, but add to 2. Those two numbers are going to be 5 and negative 3. So that's going to help us factor the numerator. So I'm going to have x squared, and then I'm going to factor x squared plus 2x minus 15 as x plus 5 times x minus 3. And then in the denominator, we have x cubed, and then x squared minus 25. This is a difference of squares, which we can factor as x plus 5 times x minus 5. Now that we've factored both the numerator and the denominator, we're going to cancel out common factors in the numerator and the denominator. In this case, the common factors that we can cancel out are x plus 5 and x plus 5 in the numerator and the denominator. And we also have the common factor of x squared in the numerator, so that will cancel out to 1. Both of those go to 1. And I'm going to cancel out 2 of the 3 x's in the denominator. So the simplified expression now is the quantity x minus 3 over x times x minus 5. And when we state the simplified expression, we need to write out the values from any factors that were canceled out and that would have made the denominator 0. In this case, we have to say x is not equal to negative 5. That's the only one that technically we have to list for the simplified expression. But when we look at the domain, we need to list any value that would have made the original expression undefined. Here it's going to be easiest to look at the denominator here in the factored form. So the domain is going to be all real numbers, except we're going to list values that are excluded. From the factor of x cubed, we're going to exclude 0. From the factor of x plus 5, we're going to exclude negative 5. And from the factor x minus 5, we're going to exclude 5. So the domain is all real values, excluding negative 5, 0, and 5. So it's important to see the distinction between what we need to write for the simplified expression, which in this case we only have to exclude negative 5. For the simplified expression, only write those values that you canceled out, factors, only those values from factors which you completely canceled out of the denominator. For the domain, you have to list all values that would have been undefined in the original expression.